All right, welcome everyone. So welcome to week 5 of the tutorial series. Today we're going to be learning about Git and GitHub, and it's a special one because we're collaborating with Incubate. So our agenda today is pretty simple. We're going to go over the tutorial just like normal, and then we're going to learn a little bit about Incubate and what they do, what they are. And then we're going to talk a little bit about their websites, which I will talk more about in a bit. But yes, and then after that, there's pizza. You guys can have pizza, chat for a bit, right? We're booked for 2 hours, so you're free to stay and chill. The reason why RecSoc is, by the way, is because RecSoc actually funded Incubate quite a bit of money, so shout out to them as well. Alrighty, so let's just get started. I will warn you guys, it's a very long topic because the goal of this tutorial is for you to learn the concept of Git and what sort of goes on underneath the hood. And so I'm not going to actually go over too much on the specific commands for you to memorize, but I want you guys to understand sort of what Git is all about. So yeah, what is Git? Git is essentially a version control system. So what it does is it tracks changes to code and allows for collaboration. So when you code software for multiple people, you want to have a system to work together, right? If it's simultaneous, right, you think of it as a Google Docs. The problem with Google Docs is that when you edit code, you break things, right? Google Docs, I can work on this paragraph and you can work on that paragraph, it doesn't really matter. But if we're working on code simultaneously and it changes instantly, I can break whatever you're working on, right? So this is why Git is centered around 3 philosophies. One is that it's distributed. So Git distributes the repository in multiple systems. That could be somewhere on the cloud, so that would be GitHub, so other people's computer. It could be on your computer, or it could be your collaborator's computer, right? We all have our own copy, and so when we make changes to the code, we can only break our own things, we won't break your code. And then we only synchronize together when we actually want to do it, right? So it's much more sort of controlled. So second philosophy is that it's immutable. Its history is immutable. So when you keep track of changes, you are not supposed to change the history. It's very, very hard to lose things in Git, right? You can try doing it, but I can pretty much guarantee you, unless you use the -- flag, it's almost impossible to lose things on Git. It tracks almost everything you do. So, and the third philosophy is that it wants to allow for branching and merging, right? So if I'm working on something, right, and you're working on something, maybe I want to build my own feature and then make specific changes to that feature, but then you're building something else and you're making changes to that feature. We don't want our sort of code changes to overlap. So I could branch off and work on my own branch, and then the other person can branch off, work on their own branch, and then we can work independently, right? So these are the 3 philosophies. Everything else centers around these 3 things. So a Git repository is essentially a bunch of commits, right? So each node is a commit, and a commit is a snapshot of the actual code. So if you have a Git repository, by the way, is just a folder. So the folder has a bunch of code, and then a commit takes a snapshot of that code. You make some changes, you take another snapshot, you take some changes, and you make another snapshot. You think that it's stored as delta, right? You think it's stored as the differences between the changes, right? So it tracks the changes. It doesn't actually track the changes. It actually has multiple copies. In this case, 1, 2, 3, 4, 5, 6, 7 copies of your code base, and it compresses it so that it doesn't take too much space. So because of that, to go back to the commit is actually pretty quick because it doesn't have to calculate the differences. But anyways, the point is, each commit is actually a snapshot of your work. So you commit, and then when you commit, the commit has a pointer to the previous commit. And this commit has a pointer to the previous commit, and so on and so forth. I'll explain what, this is sort of what you can see, what you can reason out with branching, right? You can branch off different branch and make different commits that's separate from other branches. So each commit has a reference or a pointer to the previous commit, and that's all it has. So there are 3 locations that Git files could be in. It could be either in the working directory, in the staging area, or in the actual repository. When you first download the repository, you have all the commits, you have all the folders, you have everything in the staging area, and you have everything in the working directory. What the working directory is what you actually see in your file system. So the working directory is the actual files in your computer. And then when you actually make changes, you can stage these changes, and what will happen is they will have, if you stage these changes, the changes will be on a sort of an invisible area called the staging area, and then when you commit, all the files in the staging area will be committed to the repository, so the snapshot will be taken. The reason why there's an in-between here, you might ask, like, why not just go directly from the working directory, change it, and then commit? The reason why we have the staging area is because you can make multiple changes, right? If you have like multiple files, but you only want to commit some of the changes, right? I edit like, 1.js, 2.js, 3.js, 4.js, but then I want like this commit to only have the changes for the 1 and 2.js, right? Then I just stage only those changes and then commit. So this staging area allows us to sort of commit part of our changes. So, okay, I'll move on to this in a bit. So, went over this. Raise your hand if you don't have Git installed. Okay, if you don't have Git installed, there are three options, right? You can either go on the web or you can use your package manager. If you're using Mac OS, you can use homebrew, brew, install Git. If you're using Windows, you should open up WSL2, apt install Git, right? Or a more user-friendly way, just Google Git, and then there will be a button for you to download the software. So, Git is not GitHub. So we're going to learn about two things today. We're going to learn about Git, which is completely local. It's a software inside your computer. GitHub is actually a website that allows you to store Git repositories in the cloud. It's like Google Drive, but instead of for folders, it's for Git repositories. And there are multiple of that. There's like GitLab and like other things, but GitHub's the most popular. But they're completely separate things. I'll go over that in a bit. But Git is like the software you use locally on your computer. You don't even need Wi-Fi to use it. So so if you go to Git, and there should be a download for Mac, download for Windows, whatever, it should be pretty easy to download. But once you have Git installed, you can go over to your command line and you can type in Git, and the command should work. So Git doesn't have a graphical user interface. It uses the command line. So you're gonna have to get familiar with the command line. All right, so okay, let's see. All right, so when you first install Git, you have to set some settings first. So when you first install Git, you want to initialize your username. And to do that, we do git config --global user.name and then your string, and then the string of your name. My name is Gavin Yan, right? So git and then config is a subcommand of git. The -- global flag allows this to sort of change the setting globally on your computer. And then user.name is the setting, and then this is the actual name passed into the input, right? So if you do that, what that will do essentially, if you look inside your root directory, there should be a .git folder, or sorry, .git config folder, .git config file. And in this file has all the settings associated with your Git software. So in the user.name, right, user.name. If I want to change my email, it's user.email. If I want to change other settings, it's init.defaultBranch, right? So I'm going to change some other settings. This is something that you have to do if you're working with GitHub, by the way, so it's just necessary. So git config --global user.email, and then I type in my email, right? I already have it set, but just to show you, right? What that'll do is it will write to the actual file. And then another thing we got to set is the default branch. So it used to be that Git, okay, so there are multiple branches in Git, right? The default branch, the branch that sort of is created automatically, is called the master branch. It used to be called the master branch, but then they thought it was just not a PC term, and then they changed it to main. So now we've got, like, if you install Git, you have master, but when you use GitHub, it uses main, and then you have conflicts, and it's annoying. So to change the default branch's name, you use main. So it's a more sort of modern way of doing it. So you go git config --global. Sorry? A default branch is the branch that will be created when you first create the repository. So I'll actually show you what a branch is in a bit. But the default branch is, you've got to have a branch to create anything, right? And the first branch is called the default branch. So anyway, so git config --global init.default branch main, right? These are all things you can look up online, by the way. And you can look at the Google Docs if you're curious. And this is in the repo. So that'll set the default branch to main. I'm not going to do that because I already did that. And then another thing that's really helpful is configure your code editor. So git config -- global core.editor code -- wait. So you're configuring your global, and then core.editor is the setting that essentially specifies the editor that you want to use whenever you make commit sort of messages. I know that makes no sense for now, but just bear with me for a second. What this command does is it'll open up VS Code and allow VS Code to wait, have git wait for VS Code, and then you can write your commit message in VS Code. So if you don't have this set, you'll be stuck in Vim, and you don't know how to use. If you don't know how to use Vim, then you can't quit, and it's just annoying. So, change your default code editor to VS Code. It's going to make life much easier. Okay, so you do that, and then that's pretty much it for the Git setup, and we can actually create a Git repository. So right now I am in /users/Gavin/code, right? I can create a folder. I'm going to call this Git demo, and then I'm going to cd into the demo. It's an empty folder, right? Nothing inside. So to create a Git repository, we do git init, means initialize, and it initialized an empty Git repository. And what you'll see here, if I type in ls, there's nothing, but if you type in ls-a, which is list all, you'll see here a dot folder, which is dot files and dot folders are invisible. So the dot folder, .git, is the actual repository. So you see all the data that's associated with your repositories. All the data that Git keeps track of is in this folder. So if you remove the .git folder, you don't have a Git repository. And in fact, the only thing that you need to recreate a repository is this folder. So that's the fact that we have a Git folder means we have a Git repository. So I went over this. So you can type in git status, and then you will see the status of the repository. Right now I'm on branch main, right? So when you first initialize the repository, you're on a branch. And I'll talk about how to create other branches. But right now we only have one branch, and the default branch is main. We got no commits yet because we haven't made any changes, and there's nothing to commit because there's nothing, right? Okay, so let's create something. So I'm going to open this up in VS Code, and then I'm going to create a file. So I'm going to say an index.html file, and then from here, I'm going to use the exclamation mark, right, to scaffold a template, and then here I just say git tutorial, right, and then here maybe like git, sure, and then I can open up the index just to see if it works. Perfect. All right, so at last we have an index.html, and if we type in git status, it says here that we have an untracked file. Git doesn't even know about this file, right? So we can stage this file, right? So we move it from the working directory to the staging area by doing git add index.html. Or if you do git add dot, this adds the whole folder or the whole directory, so it just adds everything to the staging area. Either way works. Type in git status, and you see here that there is a new file that's ready to be committed, right? Ready to be committed because it's on the staging area. So now Git knows about it. So now if you do git commit -m, ignore this, -m, which is the message flag, and then from here we can type in the commit message. So I'm going to say add index.html, and this will sort of, it's a message that the commit has. Every commit needs a message. Enter, and now we have a commit. So if we type in git status, we have on branch main, there's nothing to commit because everything is up to date, right? But if we type in git log, which logs all of the commits, you see here that we have one commit. The commit has a hash, which is a unique ID for that commit, and then I'll explain what this means in a bit. The author, right? You can see the author, it uses your name that we just configured, it uses your email that you just configured, and then the exact time, and then the actual commit message. So we have one commit. All right, so that's essentially how you commit. So one of this. Another way to commit, and I'll show you, if we create a style.css, right? I'm not going to actually type in anything here. Git status. I have a untracked style.css. I'm going to add that, right? And then instead of saying git commit -m and then the message, right, I can actually do git commit without the message. And what it will do is it will open up your default code editor. So we just configured it to VS Code. So now you can actually type in your commit message from your from VS Code. So add style.css. Right now it's waiting for you to close that file. You save, you close, and you commit. Yeah.
Why do you need to do it all on Git? Can't you just do everything you're doing on Git on VS Code?
Yes, you can. I'll show you that actually I'll show you that right now. If you use the command line, it's better to just use the command line to just get to know the fundamentals. There are various things that you can do on VS Code, but I'll show you how you can do these basic things on VS Code, and it's going to save a lot of time too, so you're absolutely right. We could do it on VS Code. If you do script.js, right, add another file. If you go to the source code tab, you see here that you have changes, right? U stands for untracked, so this file is untracked, and you can add, let me just get this down. Yeah, so you can, these are changes, you can add it to the staging area, you can remove it from the staging area, right? And then you can write your commit message as script.js, and then you can press commit, right? It's very, very user-friendly. And then if you type in git log, we have 3 commits, right? So you're absolutely right, we could do it on VS Code. But we're gonna later on do some more fancy stuff that is not shown here. So that's essentially how you commit. And all right, so there's another type of special file called .gitignore, and what it specifies is the files that you don't want Git to track. So if you create a file inside the root directory of the Git repository and name it .gitignore, you can list all the files that you don't want Git to know about. And when we learn backend, you'll see why that's useful in a bit. There are some secret files that we just don't want Git to know about. But let's say I don't want secret.txt, to be tracked by Git. Then if I create a secret.txt, right, you'll see here that VS Code actually grays it out, and that's because Git doesn't know about it. If I do a git status, it says I only know about .gitignore, it's untracked, but I just don't even know about the secrets.txt, right? So .gitignore allows you to ignore certain files. Maybe it's like secret API keys or secret stuff that you just don't want to push on online. You can also ignore files, or folders rather. So if you do secret / that will ignore everything that's inside the secret folder. I'm not going to show you, but you can sort of understand what that means. If I create a folder and create stuff inside that folder, nothing will be tracked. So that's gitignore. And gitignore itself is a file that you have to commit, right? So I can do git add everything, git commit -m, add .gitignore, right? Git log, and we have all these commits. All right, perfect. So now let's talk about how to restore things, how to undo things, right? So right now we have a snapshot of this repository, and let's say I make some changes, right? I make another h2, it says this is a subheading, right? And in here, I make this change, but let's say I just want to undo this change, right? Let's say I just want to I just want to reset, I want to go back to wherever my previous commit was. You can do git restore index.html, which is the file. What that'll do is it will change it back to the previous to the state which it was last initialized in the commit. So git restore index.html, and then we have all the changes gone. This is permanent. You cannot undo this, so be careful with it. And if you want to use VS Code, which is an easier way of using this feature, if you make some changes, right, maybe I link the CSS or whatever, and then I have like another h2, right? If I want to undo this change, right, there is a green thing here. You can click on that. You can undo it, right? So you can partially undo it, and then you can click on this and undo it as well. So VS Code makes it very easy, but under the hood it's using git restore. So that's how you undo changes. If you add the -- staged flag, what it will do is it will remove the file from the staging area, right? So if you create a new file, and then you git add that file, right? If you want to remove that file from the staging area back to the working directory only, then you would do git restore -- staged, and then the file. And now it will be it will not be placed in the staging area, unstaged. There we go. Okay, so that's git restore. And then let's talk about git head and branch. So if you type git status, I'm actually going to remove the file. If you type git status, there's nothing here, it's clean. If you type in git log, you see here that we have 4 commits, and then we have a head pointing to main. And this is where sort of branching, where you have to understand branching. So with the head pointer, the head thingy is a pointer, and the pointer points to a branch. And a branch is basically a pointer to a commit. So a branch is not a series of commits. It's not like, a branch of commits. A git branch is actually a pointer to a branch. So the naming of it is actually pretty awful. People think of git branches as like a series of commits. So a git branch points to a commit, a specific commit. Most of the time it's the most recent commit. And then the head points to a branch. So in the case of our repository, the head points to main, and main points to this commit. And that's all head is. Head is specifying that we are currently looking at, or we are currently on, the main branch. If I switch to another branch, head will be pointing to another branch. So we will be looking at some other things. So head represents the place that we are currently at. And main is just a pointer to a specific commit. So that's what a branch is, that's what a head is. So let's actually try creating branches. So right now we have the main branch, which is the default branch, and the main branch currently tracks the latest commit in this repository, and it's a default branch. If we want to create a new branch, we do git branch, and let's say I want to create a feature, right? And I'll just name this feature, so it's a feature branch. And we type in git branch, and we have here, you see here that we are currently on main, but there's also a feature branch. If we type in git log, you see here that head is pointing to main, and main is pointing to this commit, but feature is also pointing to this commit. So whenever you create a branch, what it will do is it will create that branch, and it will have that branch point to wherever you are currently at. And where I'm at is the head, which points to main, which points to this commit. So that's why feature and main is pointing at the same thing. So this is sort of a visualization, right? Currently, ignore the V1. Currently, we have commits, and these commits are snapshots of the code, and then master is main. The main branch points to this commit, and then we have the head pointing to the main, and then now we create a new branch, and then now we have this branch pointing to the exact same commit. So right now it's very simple, and head is pointing here. But let's say we want to switch to testing, or sorry, switch to a feature. We do git switch feature. So that'll change to the feature branch. And now we're on feature branch, we do git log. We see here that head is pointing to feature and no longer pointing to main, but they're still pointing at the exact same commit. Nothing has changed in the actual repository, right? Because we haven't made any edits. So let's say in here, let's say I want to create a new feature, right? So it's just a random feature, console.log feature, right? Doesn't matter. And then we git add, git commit, add feature.js. If we do a git log, we see here that feature is now directly ahead of main, right? So we have a new commit, and this new commit, because our head is pointing to feature, the feature branch will point to this new commit. But because we are not on the main branch is now behind. So there's nothing actually branching. Technically, there's nothing like branching off, so to speak. It's just that the feature is a pointer to a commit that's more up to date with main. So that's pretty simple. So yeah, that's just a visualization, right? You have like a head pointing to master, and then I'm switching the branch, and then making a commit, and then now the head points to the feature, and main is now behind. So let's talk about merging. So let's say I created this branch, right? Now features is now ahead of main, but let's say I want to merge main into feature, then we do, if you merge feature onto main, if we do git merge main, nothing will happen because feature is already ahead of main. So if you switch back to main, so let's say I finish this feature on this branch, and I switch back to main, and I want to merge from main I want to merge the feature branch, right? So what this will do is you're on the main branch and you want to merge feature branch onto main branch. What that will do is it will incorporate all the changes made on the feature branch on the main branch. And what it will do essentially is it will move the, because feature is directly ahead of main, it will simply move the pointer to the feature branch. So if you do git merge feature, we'll say here fast forward merge, and that's the first type of merge. A fast forward merge is just simply moving the pointer up. So now if we do git log, now main is now ahead, or sorry, main is now with feature. So before main was here, and now I switched into main, I merge feature into main, and then now main is up to date with feature. So that's a fast forward merge. It's the most straightforward kind of merge because all you have to do is just move the pointer ahead. But you can sort of imagine what happens if the branches are not directly ahead of each other, right? Let's say we diverge. Let's say the branches diverge, right? So in this scenario, for example, if we make a commit, so for example, let's say I make a commit here I'm on main, so I make a main.js, right? And then I'm gonna add this, added main, commit. So now we have a commit, right? And then from here, if we switch back to feature, we see here that we don't have main. So let's say we create feature, or maybe we edit the feature.js. Let's say we delete this, right? Doesn't matter. And then we commit that change. So now feature has nothing. Delete what's in feature. Sure. So now we do git log. We have delete what's in feature. But if we switch to main, we have added main.js. So they're diverging. Feature is pointing to something that main is not pointing to, and they're not directly ahead of each other. So we're in this situation. So now my head is on main. So if I want to incorporate the changes made on testing, and you can sort of imagine what happens if there's more commits, right? So there's more series of commits here, more series of commits there as well. So if we have diverging branches, let's say I want to merge feature or testing onto master or main. What we'll do is we'll go to main and we do git merge feature, right? Just normally how you would do it. So I'm merging feature onto main, but because the branches diverge, it will actually create a new commit, and this commit is called a merge commit. And this merge commit will automatically smoosh these two commits together into one commit. So these changes will be if there is no conflict, and a conflict means that there are changes to the same file on the same line. As long as there are no changes to the same file on the same line, there will be no conflict. It will just sort of squish together those changes. So now you can imagine that this merge essentially just adds the feature or deletes the feature, what's in the feature, but also add that main.js file. So, and then because it's a new feature, because it's a new commit, the commit needs a commit message. So now we have to write the commit message, and the default commit message is just merge branch feature, which works. So we close that file, and then now we made a merge. And this is called a three-way merge. So if you do git log, right, you see here that there is a new commit, right? Main was here, feature was here, and I was on main, and I merged feature onto main, and it created a new commit. And this merge commit incorporated the changes from feature as well as main. So now main is now directly ahead of feature. So, so if I go back to main and I merge main, if I go back to feature and I merge main, it will just move the feature ahead, right? So visually speaking, it will essentially create a new commit right here, the third commit, and this merge commit is a special commit because it points to two commits, right? Before we have commit pointing to one commit, but the merge commit is a special type of commit because it points to two previous commits, both this and this, right? So this commit points to both this and this to specify that we have merged this and this. So that's how we merge. So it's fairly straightforward, but let's see what happens if there is a conflict. So I'm going to go back to the feature, and then from here I'm going to, now remember main is now ahead of feature, so all I have to do is just git merge main to move the feature branch to wherever main is. So now it's a fast forward merge. If we do git log, we're all up to date. So let's say on the feature branch, I made some sort of like change, right? So let's say I go back here and I add like, or maybe I made some change on the main.js, right? Let's say I deleted this Git heading, and then I added this change. This is on feature branch. Delete Git heading. Perfect. So now we have feature, deleting the Git heading, but let's say I go back to main, right? And in main, I do the exact same thing. I edit the exact same line on the same file, right? Before it was Git, right? But now the feature branch deleted it, but in here I'm going to say main, right? Because this is edited from main. Then I commit that, right? Stage it, commit, changed heading. So we have one branch that deleted the heading, we have one branch that changed the heading. We are editing the exact same line on the exact same file, and that is a conflict. You cannot merge those two changes. So if you do git log, right, main doesn't even know about feature yet, right? So they're divergent. So exact same scenario here, except that these two commits have conflicting changes. So if we are in main and then we do git merge, whatever feature has, right, it will create that new merge commit here to merge these two changes. But as it does so, it will face a conflict. And it will say auto merging index.html, but then I can't auto merge it because there is a conflict. So if I go back, and we are currently in a special mode where we have to resolve the conflict. And so when we have a merge conflict, what Git will do is it will literally write these things onto the file, right? So these are not like VS Code thingies. These are literally, Git literally writes these things on the file. And what Git specifies is this is one section, this is the other section. This is where we currently are, which is main, and this is what you're trying to merge in. So you currently made a change on the H1 as main, but you trying to merge a feature branch that actually deleted your change. So you have to resolve and you have to decide what to do. And if you, for example, if I want like, oh, maybe I just want this, right? All you have to do is just delete these lines. Delete this, delete this, delete this, delete this, right? And you're done, right? Or let's say I want both of them, right? Then I just delete these and I have both of them. Or you want to make something else entirely, right? That's all up to you. You just have to make sure that the software still works. And when Git writes these text, VS Code detects these text as like special text because only Git, writes these type of text. And you can actually use this feature called the resolve editor. So here you have like two windows, and then you can see like, oh, your incoming change is that you deleted the heading, but the current change is that you changed it to main. And you can accept the current, you can accept the incoming, you can remove them, you can make something else entirely, right? But there's really nothing special about this. Essentially, all you have to do is just edit this and make sure you delete these lines afterwards. These are just to specify what the changes are, right? So let's say I want, maybe I want the main one. I don't really want this deleted heading. So I just delete all this, delete this, save that. So now I'm done. I resolved everything. I'm ready to actually make that merge commit. So to make that merge commit, you just say git commit. Committing not possible because you have unmerged files. I'm pretty sure okay, git commit -m conflict. Interesting. Oh, sorry. We made a change to this file, and whenever you make a change to this file, you gotta actually add it to the staging area. So right now the staging area doesn't even know about this change. So of course we gotta add the index to the staging area and then commit. Make that commit, and then now we'll say merge branch feature, which is the typical merge commit message. Close that. You merged it. So now if we type in git log, we create a new merge commit, and this merge commit points to both this and this, right? And you have manually resolved the conflict. So it's the exact same thing as the other three-way merge, except this three-way merge, you have conflicts that you have to manually resolve. So it's not very complicated, and those are the only three scenarios in which you are going to merge. You're either going to merge a fast forward merge, which means your branch is just simply behind that other branch and you just have to move the pointer, or your merge your branch diverged from the other branch, and so because of that, it needs to make a new commit that like sort of just combines those changes on those two branches, so it's a new commit, or those changes will have conflict, right? And it can't automatically merge those changes, and then you have to manually go in and then change and resolve those conflicts, change those like lines, and then add it to the staging area and then commit. But the result is the same. You create a new merge commit, and the merge commit essentially merges the two changes. So that's pretty simple. So a branch, right? All this time, the branch is not really a series of commits. It's really just a pointer to a specific commit. And git rebase is another way of merging from one branch to another. So git rebase allows you to essentially, instead of creating a new commit, it will essentially stack commits on top of another branch. So if you see here, okay, this is a great visualization. I forgot to pull this up. Fast forward is just, I'm on main. I want to merge feature onto main, so I just move the main pointer to wherever feature was. Get merge three-way, no conflict, is the branches diverged, but then I'm on main. I want to like merge some feature to main, and then it creates a new merge commit, move the main pointer to that new commit, and this new merge commit incorporates changes in here and in here if they have no conflict. If they do have conflict, it's the same thing, except you have to manually make this commit and resolve those conflicts, right? So it's either a fast forward or a three-way merge. So yeah, three-way is the same thing as conflict. Okay, so rebase is a way of essentially, instead of creating a new commit, what it does is just stacks the commits on top of the other branch. So if you do a git, I'm not going to show you here, but if you do a git rebase, you're basically deleting your commits and then stacking those commits on top of the other commit that you're trying to rebase onto. So if you go on feature and you say git rebase main, you're saying I want to base my commits onto the branch of main, and then you have all the commits that are not on main stacked on top of the branch. So this is useful if you want to have a clean history, right? Because you're not creating a new commit that has like two pointers. But the downside is you will never have these commits again, right? Because now feature is no longer pointing to these commits, so they're gone, they're deleted forever. So that's risky. So, and you're changing history. So let's say there's some conflict here, right? Then you resolve those conflict. But let's say when you resolve those conflict, that resolution actually broke something. And you say, okay, I want to go back to here. You can't, right? Because these are deleted. So be very careful with this. It makes a clean history. But for the most part, I would highly recommend you just stick with merge, and not mess around with rebase because it's slightly dangerous. Because it rewrites history, and it's going against Git's philosophy of having history be immutable and not changeable. Yes?
I'm a bit confused. How exactly would it cause an error? Because
Yep.
At that most point, right, we've diverged with two things, right?
Yeah.
Now we're on different branches. And if we rebase it to connect to it, right? And then we made changes.
Yep.
It seems like we in that part that's been highlighted green, that's caused issues when you try to fast forward main to where feature is.
No. If you fast forward main to where feature is, that should have no problem, right? Because you're just moving the pointer, right? What I'm saying is that let's say you have some changes here, right? Before the rebase, right? Imagine before rebasing, I just have this part, right? And let's say I want to rebase these commits onto main, right? Then what I'm doing is I am creating brand new commits. These commits are not the same as these commits. They have different hash IDs, so they're not the same commits. So it creates these brand new commits that incorporate the changes of these commits. And if there's no conflict, it will just automatically merge in. But if there is conflict, then you have to resolve them, right? But either way, these snapshots are not the same as these snapshots. So let's say it merges automatically or resolves some conflict, and now you're here, and now feature branch is here, right? But then let's say your resolution of those conflicts broke the software, right? If your resolution broke the app, and I say, okay, I want to undo my rebase, you can't undo your rebase because these commits are gone because nothing is pointing to them.
So the main these had an error that occurred when you're like messing around in the feature and that broke everything, then you don't have to worry about like going back and fixing your main branch because you can just fix what's wrong with the feature.
Kind of, yeah. Like, maybe if you look at the merge, you'll see why. If this broke, the software, you can always go back, right? Like, let's say I made some feature. What I'm saying, the breaking part is the merging part. Like, when you merge two things and you resolve the conflicts, or when it automatically merges, let's say it just breaks the thing. But when you break that thing, you can always go back here, right? Because when it just creates a new commit, but everything is stored. You can go back here, you can go back here. But if you're doing a rebase, this commit is gone. So if these broke things, you can't go back here. Does it make sense?
If you wanted to go back, you could only go back to main, but that would mean you would lose your feature.
Exactly.
Okay.
Yeah. You can go back main because because this is pointing to this and this is pointing to this, and main is pointing to it. But nothing is pointing to these. And in computer science, if nothing is pointing towards something, the computer thinks it's nothing, and it just get garbage collected. So these are gone. So that's dangerous, right? So anyways, it's not technically gone. You can still retrieve it in some way or the other with reflog, but that's complicated. You just don't want to mess with that. Yeah.
So does rebase under the hood use merge because it adds the feature commits ahead of the main commit?
It doesn't use merge under the hood. The algorithm that allows changes to be merged is the same algorithm. But instead of creating a new commit, it just deletes your commits and then stacks new commits on top of that branch. So the algorithm in which it allows to merge content is the same, but it's not the same in that merge creates a new commit. Does that make sense?
Yeah.
Okay, perfect. So is anybody confused?
Yes.
Okay, do you understand merge?
It's okay, I'm really tired.
Okay. Yeah, it's not a simple concept. But anyways, it doesn't really matter. The key thing to know is that a branch is just a pointer to a commit, and a merge is just a new commit, right? So, and you don't have to know about rebase if it's too complicated. So anyways, so that's rebase. There's also interactive rebasing. I'm not going to talk about this. It's very complicated, but essentially it allows you to change history, right? So that's going against Git's philosophy, but interactive rebase allows you to interactively change your Git history, delete some commits or like reorder commits even, but that's too advanced. And then there's Git stash. So this is something that you will encounter quite a bit when you're using Git, is if you're on main, and let's say I make some file, and the file is, what I'm going to do is on the feature branch, I'm going to create, I'm going to make some, some changes, right? Console.log change from feature. And then I add that and commit it. So now I made some changes to the feature branch. And then I'm going to switch back to main, right? So now feature is now ahead of main. If I made some changes, so let's say I create a file here, name it like main, another main. And then, so now I have some sort of, or maybe not, I won't create a new file. I'll just change like the main.js. Okay, so now I have some unsaved changes, right? Like I'm in the middle of working on something, and then let's say like someone tells me, oh, check out my feature branch. I want you to test out my feature branch. But you're currently working on main branch. So you want to check out the feature branch. So you do git switch feature. But the problem with this is you have unsaved changes, right? So when you do that, Git will warn you, or I guess it will actually switch. But when it switches, it will bring your changes to that branch, right? Assuming it doesn't conflict. And maybe you don't want to, when you switch branches, you don't want to bring your existing changes to that branch. It's just messy, right? So if I go back to main, git stash allows you to stash your changes, put them away, and then change to another branch, and then do whatever you want, and then go back and then apply those stashes, right? So right now I have some changes, right? If I do git status, I have some changes. Let's say I want to check out the feature branch, but I want to save whatever I have now. I just type in git stash, right? And it will stash away my changes. So it looks like my changes are gone, but it's saved. And then now I can go back to the feature branch safely, right? It doesn't carry over my work. I can do whatever I want with it. I can check the actual feature, right? And then whenever I'm done, I can always go back to main, and then I can go back to main and then apply that stash. Git stash apply or git stash pop. Pop will actually delete that stash after you apply it. Apply it will just save it. So git stash pop, and then now it applies those changes, right? This is extremely helpful if you're working on multiple branches and you want to switch branches, but you want to like save your work for a moment before you switch to another branch. So that's stash. And let's talk about how to go back a commit. So to go back a commit, we need to use the git checkout. So to use git checkout, we're going to do git. I'm actually going to undo this change just to have a clean slate. So git log. Okay, let's say I want to go back here, right? Doesn't really matter, but let's say I want to go back here. You copy the hash, save it, copy it, go back, git checkout, and you paste in the hash. And now you're on that branch. You're on that commit. And now you're in what's called a detached head state. What that means is your head is no longer pointing to a branch, but it is now pointing to a commit. So in this state, you can do whatever you want. You can make whatever changes you want. But if you commit, your head will be pointing to that new commit, but no branch will be pointing towards it. So if you decide to switch back to the main branch, nothing else will be pointed towards that commit, and it will be lost, right? So when you're in this detached head state, typically when you want to go back commits, you just want to check out what's going on. Maybe you don't want to make changes. But let's say you want to make some permanent changes off of this branch, off of this commit. Then what you want to do is create a new branch, right? When you create a new branch, it will create a new branch pointer to wherever head is currently at. And then now you can save it forever. And now when you make changes, that branch will also update, right? Does that make sense? Kind of. So when you're in a detached head state mode, you type in git log, right? Head is pointing to this commit, but no other branch is pointing towards it. If I switch back to main, nothing happens. But if I make a change, if I make some sort of brand new commit, the head will point towards that brand new commit, but then the instant I switch back to main, nothing will be pointed towards it. Yeah.
Wait, so, okay, for one, like, does git log show like all logs in the entire repository or only on the current branch?
Git log looks at where head is pointing towards, and then goes down from there.
Because like, just here, because you can like check out a certain commit.
Yeah.
So let's say if you like rebased something, could you get the hash from the like loss commits and then go check out that and restore it that way? Because when you
No,
rebase,
because
there's nothing pointing at those hashes, but if you still have the hash, could you then go check out the loss hash?
No, because you won't have the hash, and the reason why is because when you do a git log, it will go to wherever the head is pointing towards, right? And then it will log all of these commits.
Okay, so just like searches and tree.
Exactly. That's why there's a pointer pointing to the previous commit. That's all it does. It's go back to the pointer, to the previous commit, and then the previous commit, and then previous commit, all the way down. It won't show this because it's not pointing towards it. So git log doesn't actually show every single commit. And you see here, right? My head is pointing towards a commit, but this commit has pointers to other commits, but it doesn't actually show me where head is, right? So this is another example of where git log doesn't actually show you all the hashes. So anyway, so that's a detached head state. And if you want to make permanent changes, you just create a new branch and then make some changes from there. But whenever you want to go back, you do git checkout main, or you can do git switch main, doesn't matter. And I'm back on main. Yeah.
So this is like going back without like merge and rebase.
Yep.
So let's say like you had like some code and you wanted to make a change. So you'd first like make like a branch to create those changes. And let's say like they were like small, like it like basically doesn't matter, like it's like super small things.
Yeah.
So then once you have those and then you merge it back to like the main branch.
Yeah.
And like let's say you check that main branch works.
Yeah.
Could you undo like the merge and then rebase it now that you're like sure that that won't like do anything wrong basically? And
Yes.
you don't really care about those. You don't really care about having those changes like stored as like you don't really care to go back to those to ever like see what you changed.
Yes.
So,
Yes,
yeah,
you can.
okay.
Yes.
I basically understood it, right?
Yeah. Okay. Yes, that you can do that. The thing is, like, that is a lot of work because you have to go back to that branch, you have to merge and create a new merge commit, and then everything works. And sometimes when you think things work, they break later, so you never really know. But let's say you think that works, and then you have to go back to the what feature branch was, and then you have to rebase it off of the commit where it is not on the feature branch. What,
Can you not just delete like the merge that you like the new like snapshot merge that you created?
you can't delete commits, you can move branches to point to another commit so that nothing is pointing towards it. Yeah, and that commit just is gone. And so you can delete it by manually going to that merge commit, and whatever branch is pointing towards that commit, you move that pointer back, switch back to that branch, and then rebase it. Like, why? So it's a lot of work for nothing, just to have a cleaner sort of Git tree, but no one ever looks at Git trees anyways. So anyways, so yeah, most of the time, if you're in like a hackathon or something, right? You'll just do git add, git commit, git merge, and that's it. You don't have to mess with rebase. Stash is something very useful that you may want to use when you just want to save the changes. And then maybe sometimes checkout when you want to check out like a specific checkpoint. And stashing, by the way, you can stash it before you check out, right? So you can like say, oh, I want to go back to that previous commit, but I've done some changes that I haven't saved yet, so I'm just going to stash them away, git stash, and then I'm going to check out the other commit, and then come back and then stash apply. So anyway, so that's how Git works. And a typical feature branch collaboration workflow is you'll have the main branch, and then whenever you want to create something, create a feature, you create a new branch, and then you create commits on that branch. And then whenever that sort of feature is ready, you merge it back to main. What that'll mean is you will merge main onto feature to make sure that the conflict works, or that the merge works, it doesn't break anything. And then once that's done, you can go back to main and then merge feature onto main. And that will be a fast forward merge, because it will just move to the merge commit. So, and this is a merge commit, right? This is an example for merge commit, because it points back to both this and this. So if you do here, and then git merge, right, feature branch will be pointing towards this, main branch will be pointing towards this. In the feature branch, you can check, okay, everything in here works, then I can say, go back to main, and then just move that main onto here, a fast forward merge. So that's typical of a general workflow. And then every single tiny little feature is its own branch. But honestly, if you're dealing with like very fast development in a hackathon, for example, you maybe want to have like a branch for a specific person, and then merge into main occasionally from there. Or you can have like a branch that's like develop, that's more experimental and sort of developing, and then whenever that's ready, you can merge it back to main, right? And so instead of feature based, it will be more like develop based. That's all up to you, right? It's all up to you. But on a big project, I would say either this or the feature branch. And if it's on a small project and you have to move very, very fast, maybe just like each person has their own branch, and then you can like merge in whenever you're ready. So that's a typical workflow. So that's it with Git. And now we can actually talk about GitHub. So GitHub is, like I said, it's basically Google Drive, but for Git repositories. So if we go to GitHub, I have an account, but if you don't have an account, you can register for one. And GitHub, the landing page looks like this if you don't have an account. And has a lot of AI stuff now, but anyways, it's just a platform for you to push repositories onto a centralized platform. So let's say in here, Replit. Yeah, Replit is another one. Replit allows you to code interactively, so it's literally like Google Docs. But GitHub allows you to just store that repository. But yeah, Replit is another one. So with GitHub, to set up a GitHub account, you have to create a GitHub account, and then you have to set up your SSH. And if I won't go over that because it just takes too long, but if you go to the actual repository, you'll see the installation instructions for Git, and in here you can also see instructions for how to set up SSH for GitHub as well. And it links to the direct docs. But what SSH is essentially a key that allows you to identify and authenticate you onto GitHub in your command line, right? So right now, it doesn't really know that my command line is logging to GitHub. To do that, to log into GitHub in the command line, you have to do this SSH setup. And it makes it pretty clear what that means. And essentially, if you want to know like the overall gist of it is you create an SSH key pair, so private key, public key. You put the public key on your account, you save your private key on your computer, and then whenever you push, you send that private key, and they will check that private key against the public key that you put on your account. And then they'll say, oh, because you have that private key that's associated with the public key, you must be an owner of this account. So that's how it works. But anyways, once you have it set up, you can actually create repositories and then push them onto GitHub. So the best way, if you are creating a repository and you already know you want it to be on GitHub, I would recommend just creating on GitHub first rather than pushing an existing one. So to create a GitHub repository, you just click on New, and then I can say, GitHub demo, right? You can have a description, you can make it public, private, you can add a README file, and you can create the repository. And then now you have an empty repository on GitHub servers, and you have access to this, right? So to copy down this repository, you copy the link, go back. I'm gonna go back a directory and I'm gonna clone it here. So I'm gonna do git clone, paste in the URL. And I cloned it. And it says, warning, you have cloned an empty repository, of course. And I'm going to go into GitHub demo, and it's an empty repository. But it does have this .git folder. And so now in this .git folder, I'm just going to, now in this repository, I'm just going to make some changes, right? Let's say I created a file, and then I git add. Doesn't matter. Okay, ignore that.
So people code the code that they put on, like their projects that they put on GitHub through this?
Yeah, through on GitHub. So their code is on GitHub, and everyone can see it if you make it public. So it allows your code to be like public.
Can you put like any code on it?
Yeah, you can put anything on it. Yeah, anything. So yeah, I create a file.txt. I do a git log. I created that commit, right? And in this commit, or I have this commit, and then I'm gonna push it. So I'm gonna do git push. Because I cloned it from this remote repository, it already knows where to push, and I have authenticated with SSH. So you do git push, and it just pushes that commit. I go back, I refresh the page, and I have file.txt here, right? So, and then you can imagine everything else is the same. Whenever I add things, I can commit, and I can push it, and then when I push it, it's on the repository live. So there is a difference between the local repository and the remote repository, right? So you can make commits, but if you don't push them, they will not be shown on the repository. And there's also a difference between the branches here and the branches locally. So if you create a new branch, you won't have that branch here unless you push it. If I do a git log, right, you see here the difference. Head is pointing to main is pointing to this commit, but origin/main is also pointing to this commit. So origin/main is actually the remote repository's main. Origin is the remote repository. And this could be behind, this could be ahead, right? So they're separate things. So there is a README file. So README allows you to essentially write descriptions about the repository and what it's about. So you can do touch README, and in here, maybe I want to add in like hello, right? And I save that. I'm just writing it. So now I have like hello in the README, and I'm going to do git add, git commit, add readme, and then now I have it. But now I'm ahead of the remote repository, and so I'm going to git push. And by the way, if you push, you can sort of think of it as a merge, and this will be a fast forward merge. If there is conflict, it will not allow you to push. If there is conflict, it will say there's a conflict, please deal with that conflict. But there's no conflict here because it's a fast forward merge. Git push, and then you can git log, and now it's a fast forward merge. If you go back, refresh, you can see there's a README file, but then you can also see a description here. So that's sort of like when you go to repositories, you can see like a long description of that repository. That is all essentially written on the readme.markdown file. So that's essentially how README works. And pushing a new branch is a little tricky, right? So if I create a new branch and I switch to it, right, and let's say I make some changes and then I do git push, it'll say you can't do that because there's no such thing as a feature branch on origin. So instead you have to do this, and essentially it sets the feature branch to track the remote repository, which is origin. So set the upstream to origin, so that feature branch tracks the origin, the remote repository. But you don't have to understand it. You can just try git push. Doesn't work. Oh, I'm going to copy this command and it'll work. And then now there's a feature branch on this repository. So now there's two branches, there's a feature branch, and currently they're pointing at the same thing. So there is also pull requests. So pull requests are a concept in GitHub, not Git. And pull requests is essentially a request to merge one branch to another branch. So if I am in a feature branch and I do some changes, let's say I open this up in VS Code, and then in this feature branch I say this is a new feature, and I save this new feature. And then if I do git log, right, now I have feature branch, it's ahead of main. If I do git push, git log, now I have the origin feature branch and the feature branch together, but they're ahead of mains. So if you go back, you can see here that feature has recent pushes, and you can actually make a pull request. So a pull request, like I said, is a request to merge one branch to another. So if you make a pull request, what this will do, you'll see here that I'm trying to merge the feature branch onto the main branch. And it's just a request to do that. And you can actually just make discussions, talk about it. You can summarize your changes. So here I made some changes and added some feature, right? You can just write what you did. And you can create that pull request. And then other people who are working together on this repository can see this pull request. And it'll say, oh, new feature, let's check it out. So this pull request wants to merge the feature branch onto main branch. And so it has one commit, new commit, and here are the files changed and everything. You can even comment and sort of talk a little bit about it. But once everyone's ready and like, okay, we're good to go, you can say merge pull request. What that will do is essentially merge feature or merge merge feature onto main. So incorporate the changes on feature to main. So merge pull request, confirm merge, and then now it's merged. There's no magic here, it's just a git merge, but it had an extra layer on top of just like I want to request doing it before I actually do it to make sure that people don't yell at you because you broke something or something. So, so yeah, if you go back, it's a merge commit, and even though it's a fast forward merge, it creates a new merge commit just so that there is a record of that merged pull request. But it is a fast forward merge. So so merge pull requests, yada yada yada. So that's essentially what pull requests are. Yeah.
So since you do the merge on GitHub, how is that reflected in your local repository?
So okay. So right now it's updated, right, on the remote. Right now I'm out of date, and whenever there's things happening on the remote, and I'm out of date, you got to do git fetch to download what's like happening to make sure that you're up to date. So it sees that, okay, there are changes, and download again. Okay, now that I download it, I look at git log, and you see here that my head is pointing to feature, but it doesn't have that yet, right? So if I do a git pull, what that'll do is it will fetch the data, and then it will merge whatever is on remote here onto the local one. And because it's a fast forward merge, it will just move it up to date. So if I do a git pull, by the way, on the feature, we're all up to date, right? We're really talking about main because we merged feature onto main. That's what the pull request is. So if we go back to main, you can see here that it's not merged yet. But if you do git status, you can see that your branch is actually behind. So I checked out the remote branch, and it seems like there are actually 2 new commits on that remote main branch. And the 2 new commits are the commit from the feature and the actual pull request commit. And if I do git merge origin/main, right? Or I can do git pull, which is fetches the data and then pulls it, the branch that's associated with the remote. Either one works. And it just fast forward merges. And then now my head is pointing to main, which is pointing to this, which is pointing to the new pull request commit. Okay. So yeah, so whenever there are like online changes, you gotta fetch, and then you gotta make sure you merge. And then there may be conflicts there too. And so yeah, whenever you want to collaborate, you go on settings, and you want to add collaborators. So you go on collaborators, and I gotta use extra authentication. But then you go into collaborators, and you can add people, and you can find their GitHub account with their username. And then once they're added to the repository as a collaborator, they can then push to this repository and collaborate. So forking, we're almost there. Forking is, let's say I go to React.js, right? Raise your hand if you know React. Yeah. So React, if I go to their repository, React is actually open source. So if I go in their repository, they have 19,000 commits with 335 branches, massive repository, and they have a massive README too. And so let's say I want to contribute to this repository, right? I don't have direct push access, but I can make a pull request, right? If I make a pull request, they can actually check what I edited, and they can actually check, okay, this person made these changes and seems to be passing all the tests, and then the people who actually have push access will approve of these changes. So to contribute to open source software, you have to make pull requests. But the problem is I can't make a pull request because I don't have access to this repo. So to do that, or to track your commits, you're gonna have to fork this repository. So if I do a fork here, I can fork this repository, and what that'll do is it will copy that repository onto my account. So it's a copy of that repository, the React repository, but it's under my account. And because it's under my account, now I have access to actually push new commits onto it directly. So if I go here, git clone here, right? Everyone has the right to clone it, but not everyone has the right to push commits onto it. So, but I'm cloning my own fork. So now I have access to the, now I can actually push stuff onto it. So if I, oh my goodness. So if I go to React, and I see all these files, and then like, let's say I made some change, right? And then I made some stupid change to React, right? I can actually push, right? Git push, and it worked because it's under my account. And then it will see that, oh, you created a new commit. You can actually contribute by opening a pull request, right? And so if you make a pull request, surprisingly, a pull request can actually request to merge between branches of different repositories, right? So this pull request requests to merge my branch onto the, like my repository's React main branch onto the React repository's main branch. And then I'll write about what I changed, and then I'll create pull requests. I'm not going to do that because I don't want to annoy the team of React, but you just click a button and it will be sent. So that's essentially how you'd contribute to open source. Issues, so if I go back here, there are also GitHub issues. These are basically, if I go on the React repo, you see a ton of issues, and anyone can open an issue. And issues are essentially either bugs or glitches or sort of things that you would want, like feature requests, anything that you want the person to know about. So for example, oh, there's a compiler bug, and these are the things that sort of like what's going on. And then people who are contributing or want to contribute, they can look at issues and be like, oh, maybe I can fix this, and then I can fork it and then make a pull request, something like that. And so, yeah, that's issues. And then there's also actions. This is the last thing. If you have a repository, what you can do is, if I go to the GitHub demo, there are actions, and GitHub actions are essentially, they're GitHub features that allow you to do certain things when you make a commit or any other action. So for example, when you make a commit, maybe you want some tests to be run. GitHub actions allow you to automatically run those tests after you commit. What is really cool is that other platforms such as Vercel or Netlify incorporate GitHub actions onto your repository so that whenever you make changes to, for example, a website, it will use GitHub actions to automatically deploy your website whenever there are new commits. So the thing that allows that to happen is GitHub actions. You don't have to manually mess with it, but it's just something that you want to know about when you're actually deploying apps, because it'll be something that's attached to your repository. Whenever you commit, it will be deployed. Okay, we're done with the tutorial, very long tutorial, 1 hour and 15 minutes. Hopefully it's been informational and you've learned something. But yeah, so I'm gonna actually pass this on to Evan because we actually haven't talked about Incubate at all. So yeah, so I have Evan introduce what Incubate is all about.
So firstly, thanks Gavin for allowing me to do this and great workshops. So hi, I'm Evan. I'm the co-chair of Incubate. We're a club here at Queen's, and we focus on helping students who are interested in building a tech startup. So just a little story about what we do is we have a bunch of startups that a lot of our members are currently building up, but we also provide them with unique opportunities. So for example, last week we actually had our Toronto Firm Day that Gavin here also attended, where we partnered with Autodesk and Ripple. And yeah, we got to visit both their offices, learn more about their internship programs, and meet some pretty cool people. So there's the Autodesk office in Toronto, and there's Ripple. Ripple is a venture capital firm that basically provides startups with funding. So what we're looking for right now is a lot of you are looking for hands-on projects. So as Gavin mentioned, React, we're looking for individuals who are interested in taking on development projects for Incubate. So our primary one that we're currently focused on is our website. This has been a project that we have pushed off for far too long, and it's also at the fault of mine and our in-house graphic designer, who, when he designed our website, made it really complicated. So for anyone who's interested in giving us a hand, learning about React, learning about how to work on a team and utilize tools like Git for a larger scale project, yeah, just, where is it?
It's right here, yeah. So if you wanna have like a project that you can show off on your resume, it's gonna help a lot. Raise your hand if you're interested in internships, like you're searching for internship. Wow.
Nice.
Oh, okay, there you go. I was like, I was looking at the only people who are not raising their hand. But anyway, yeah, so like having projects on your resume is gonna be super important, right? With internships, I would say there's like 5 things fundamentally. Your resume, your projects, your leak code, neat code, whatever, your networking skills, and something else I'm forgetting. But anyways, projects is one of them, right? So having this on your resume is gonna help a lot.
For sure.
Yeah, if you scan the QR code, it will send you to a Google form, and if you sign up, you might get, or you will get, I think, an exclusive invitation. You actually contribute to the website. An exclusive invitation to one of Incubate's future events. I'm not sure what that is yet. Things are yet to be finalized, but it will be something cool.
Yeah, for sure. And just to add on to what Gavin said, I guarantee each one of you will have to create a personal website at one point. I have my own, Gavin has my own, and this is a great opportunity to get your hands wet in a safe environment. On top of that, Gavin mentioned that we would invite you to some of our upcoming events. John, actually, who has been helping us on the website, who's from QWeb, he got to go to Autodesk with us as well. And Ripple, John, how would you say the experience was?
It's a good experience.
It was a damn good experience. So there you go. If you help out with that, you will also be invited to some of those opportunities. And just for a sneak peek of what's ahead, no guarantees yet. I'm still finalizing a
Can't believe
date.
you're saying this.
I gotta put pressure on myself. But I'm currently finalizing a date with Veritasium to do a fireside chat.
Raise your hand if you know Veritasium. If you know, yeah. Everyone he's a nerd.
So yeah, if you guys want to be invited to events like this, give us a hand on the website.
Stan,
Please.
we need that website up. But yeah.